We're going to perform electrical safety testing on the Valleylab FT10 using the Pronk Safety Sim Safety Analyzer. What we want to do first is configure our testing per the manufacturer's procedures for the Valleylab FT10, and we're going to utilize the Pronk Mobilize app for all of that programming we need to do to perform the testing per the manufacturer's procedure. The Pronk Mobilize app is available on the App Store. You can search for it by entering in Pronk Mobilize to download the app. Once you've downloaded the app, you would go to the Setup menu to connect the Pronk equipment to your Apple device. And under Device Connections, you'll see Safety Sim. And in this blue box here, if you tap on it, you'll see a list of devices available to connect and pair to. The ID of the device you need to pair to equals the serial number on the back of the Safety Sim itself. So you would find it, select it, and then hit pair. And that will connect the Safety Sim to your app and to your mobile device, and you'll know it because the light will turn green here. As a quick footnote, at the top here is information that you want to customize. This information gets added to all of the electronic service reports. As the testing is being performed, a report is being generated and will be saved on the Mobilize app as well. Once we've kind of configured and paired our app, the next thing we want to do is set up our electrical safety test. This can be done through Edit Device Types. Tap on that, and at the very bottom you'll see Customize ST Profiles. Here you'll see a list of electrical safety auto sequences already created and saved. If you want to create a new one, you would simply hit New to create a new additional electrical safety sequence you can add to your library. For our purposes, we already created the FT10 procedure, but let's take a quick look at it and see what test we're going to perform. So you tap on Edit, and you can see at the very top here you have the name of the profile. We've already gone ahead and given it a name that would be easy for us to search and identify so we know what test we need to perform. Below that you have DUT on time, which is how long do you want the test to perform before it advances to the next test. Because the ESU we're testing has a longer boot up time, we've gone ahead and set it for 30 seconds. The next thing you want to do is select DUT on-off repeat, whether you want to turn that on or off. This requires you to do the safety testing twice, once with the unit off and then again with the unit on if you have this box checked. In our case, for this device, we only need to do it with the device on. So we'll leave that off. The next field is DUT power at end. We always recommend you enable this field, as this will allow the power plug to remain energized after the safety testing, leaving the ESU unit powered on if we want to do any functional test afterwards. Sim auto sequence is for simulation. Of course, we don't need to do that, so we'll leave that off. The next limit is ground resistance test, or what they refer to as ground bonding test. We've set the limit per the manufacturer's requirements at 300 milliohms as well. Below this are the tests that we have to run per the FT10 service manual. And you have here the names of the different tests we could be running, from earth leakage, chassis leakage, to lead leakage to ground, or what's called leakage sink, leakage source current, I should say. And then you have lead leakage ISO, lead leakage sink. It can be referred to in the service manuals. To the right of that is what is the condition of the ground line for our testing. You could have it closed or open. For earth leakage, it doesn't apply, of course. And you have neutral, you could have it open and closed as well. So you can select what is your fault you're going to run. You could also do it in normal polarity and reverse polarity. And over here to the right, you would set your pass-fail limit. So for the purposes of this FT10, we're going to run a chassis leakage test. It gives us the option to run earth leakage or chassis leakage. We're going to run chassis leakage tests, and we're going to do it in normal conditions with both the ground and neutral closed. And we're going to do it in normal polarity, not necessary to do reverse polarity, so we're going to leave that off, and we've set the limit to 300 microamps. That's one test. The next test is we have to also do chassis leakage test with the neutral open. So that's why you see this configured open here. We're going to do it again in normal polarity. Reverse polarity remains off, and the limit in this test is 1000 microamps. The next test down is the lead leakage to grounds test. We need to do this in normal conditions, and so that's why you have ground and neutral closed. Normal polarity only again, and the limit is 10 microamps. Also need to do it with a fault condition, which will be the ground open. So we're going to repeat the same test with the ground open the second time. In normal polarity, the limit is 50 microamps. And then the very last test is a lead leakage ISO test, or a lot of times it's referred to as a MAP test, a main unapplied parts test. This is where we're taking 120 volts AC and applying it to the leads. And in the case for this test, we need to do it with the neutral closed in normal polarity, and the limit is 50 microamps as well. So once we've configured our test, we could save it, and now we're ready to perform this test on the ESU. Before we do that, of course, we need to connect our ESU up to this electrical safety analyzer here on the left side. We want to connect our red test lead cable to the back of the unit to the ground post on the back for our ground resistance testing. And then we need to connect what they refer to as all the outputs or applied parts to the electrical safety analyzer. And we're going to do this using a set of different banana to banana lead wires, connecting each port to the safety analyzer applied parts section, which is up here in the ECG snaps area. So to do the first port on the FT10, you have to use a special adapter for the very far left port on the monopolar one. So we'll need to have this plugged into this side, and then we could connect our banana plug to that. And then the right side goes into the far right port, and the same thing is true for the other ports. You put a lead wire in the far left, and then in the far right for bipolar, same with monopolar 2, and same with the lower right hand port. And of course our REM line, you want to connect two test leads to that as well, all connected to our electrical safety analyzer here on the left. So you connect it to the snaps. It doesn't matter what snap you connect the wires to, they can connect in any order you want to by simply just taking a banana plug and sliding it in underneath the snap. So there's enough room to connect all of the leads to the electrical safety analyzer to do our testing. So we're ready. The next thing we want to do is go back to the app and start a test. You can do that by tapping on the asset ID field and manually entering in the asset ID, or if you have a scanner, you could use the built-in scanner, I should say, of the Apple device, hold it up to the barcode and scan that asset so we're actually capturing that serial number information. The next thing you want to do is go into the safety only mode and then select app profiles where we created our electrical safety test sequence and select it here down below. Once we've done that, we start the test and the analyzer will wake up and automatically start the first test. In this case, you can see via the Mobilize app, it's running the ground resistance test. In the center here is the measured values, and it's going to perform that test. Once we get to the next test, we want to go ahead and power on the ESU unit so that we could perform the rest of the testing that we need to. And you can see on the app itself, it's going to be performing each test that's required per the manufacturer's procedure that we just created via the Mobilize app. So this first test here is a normal polarity chassis leakage test in normal conditions. And you can see here is the measured value it's getting. Since we selected to do a longer boot up time to allow the unit to boot up, you'll see that each test will take a little longer to run, accommodating for the time for the device to actually turn on and boot up completely. So as the unit is turning on, you'll see it's performing each individual test, and again it's capturing each individual result, and it's collecting this information so that at the end of the testing we're going to have a complete electronic service report. It's important to realize too that part of these testing includes energizing the applied parts, as we say, to main unapplied parts, as I mentioned earlier. This is where these leads will get energized to 120 volts AC. So you want to make sure you're not touching those snaps during those tests because it is applying mains voltage. It is current limited with 120 k ohm resistor inside of the unit, but nonetheless you'll want to avoid touching them and having a problem with that. So you see here, you may see a REM contact quality error here, and that's because we do have the REM line shorted to the safety analyzer. That's normal. It won't affect your leakage measurements, so that's not going to impact the measurements at all. Just let it continue through the safety test as it's going through it. You can see here you have the warning letting you know the leads are hot, so just a reminder not to touch the leads. And it's just going to go ahead and perform all of those tests that we need to. And it's performing a lead leakage test in every single output port making sure that it meets the manufacturer's requirements for that test. And again, these tests are running a little bit longer because we're allowing that ESU unit to boot up completely. So you're going to run through all these tests and make sure we've captured all of the results and that they're within the manufacturer's specifications. You can see here it's going on to the next test, which is doing a chassis leakage test, but with the open neutral. That is why the ESU powered off, because the service manual requires us to do the chassis leakage test with the neutral line open, so the safety sim automatically opens up that neutral line for us to run that test and collect that result. So it's normal for the ESU to power off after that test, so nothing wrong because it does that. So we're going to let it continue and finish the testing that's required so we can capture all this information. So once it's complete, you'll see it goes to the service report, and you'll be able to see all your information here about what testing we did. You'll also see on the safety analyzer itself, if all of the tests pass, the unit will stay green. If any test fails, it will stay red, indicating something is out of range, out of specifications. The same thing on the app. The app will indicate green for a pass, a fail if any one or more tests fails. And here in the center are all of the tests we ran, your measured values here, and then your test limits, your pass-fail limits here on the right. So we've completed the electrical safety testing on this FT10 ESU analyzer.